Hello everyone, welcome back to Hike. My name is Pranjal Jain and today we are going to solve a question named generate parenthesis. So it's a very interesting question. We are going to use the concept of recursion and backtracking to solve this particular question. So watch the entire video. First of all, we'll discuss the question, then we'll even look at the code. So let's have a look at the question. Given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. So for n equal to 3, they have given us a certain number of parentheses that are possible. So let's take this example and try to understand the question. So for n equal to 3, so we have to give all the possible perfectly formed parentheses of length 6. So there are going to be 3 pairs of opening and closing brackets. So the total length is going to be 6. There is just one rule that we have to take care of at any point in time. You have to just take care of one thing. Number of closing brackets has to be less than or equal to number of opening brackets. This has to be maintained throughout the string for any particular index throughout the string. This rule cannot be done away with. For any point in the string, the number of closing brackets will have to be less than or equal to the number of opening brackets in the string. Let's take an example. For example, we have this string. Now the total number of opening and closing brackets are perfectly 2 in 2. But at this point, we have 2 closing and 1 opening bracket. And that is why it is not a valid parenthesis set. So let's see for n equal to 3, how many valid sets do we have? So first of all, 3 brackets next to each other. Now let's start nesting these brackets. Next, we can nest all of them. And then, so these are the valid parentheses of length 3. So like this, a number will be given to us and we have to return the valid parentheses. How are we going to do it? So let's have a look at an example with length equal to 2, n equal to 2. So initially we'll call a function with no brackets at all, okay? So initially the string will not contain any bracket. So every time we have to explore 2 possibilities. Either you can add an opening bracket or you can add a closing bracket. Now, in this particular string, the number of closing brackets are greater than number of opening brackets. So it doesn't matter how much you grow towards it. So after you put a closing bracket, at this point, number of closing brackets are greater than number of opening brackets. Now it doesn't matter what you put in front of it, it will never become valid. So basically we prune this particular branch, and as soon as this condition is met, we will stop going further into the branch. Let's see what we'll do next. So again, we have 2 options. Either you put an opening bracket or you put a closing bracket. Again, let's explore one of the branches. From here, you can put an opening bracket or you can put a closing bracket. Now you look over here, the number of opening brackets is greater than n. So we will prune this branch. We won't explore this any further because we have more opening brackets than required. We need 2 opening and 2 closing brackets. Here we have 3 opening brackets. So let's explore this particular branch a little further. Again, we have 2 options, opening brackets and closing bracket. So this branch, again, you can see there are 3 opening brackets. We'll prune this, and like this, as soon as we get to a condition where there are 2 opening and 2 closing brackets, we know that this string is part of the answer. We'll add it to the vector and return that. So let us see how we can code this thing. So look at this very carefully. So it's very easy. Normally the codes that involve recursion and backtracking, they're very easy once you get a hang of this particular topic. So let's see how we can get this done. First of all, we'll declare a vector of strings. In this vector, we'll return the answer. So let's name it answer itself. Then we'll take a string str where we will store the current string that we are considering. Let's call the recursion function. So recursion function will not basically return anything. It will just modify our answer vector. It will put all the answer strings into that. So first of all, we are sending answer, then string, then value of n. Then basically how many opening brackets do we have? Right now it's 0. How many closing brackets do we have? Right now it is 0. So if we need to send anything else, we'll do that later. Let's start creating this recursion function. After the recursion function is over, we'll simply return the answer vector and we are done. Let's create the recursion function now. So to create this function, it is a void type of function. The return type is void. It will not return anything. So let's make a vector over here, vector of string. Then we have the string, then n, then number of opening brackets, let's mark it as O, and number of closing brackets, let's mark it as C. Now the first thing that we have to check is if at any point in time opening brackets become greater than n or closing brackets become greater than opening brackets or length of the string becomes greater than 2n. In all of these conditions, we simply return, we simply prune this particular branch. We don't explore this any further. If this is not the case, then we'll write the base condition or the stopping condition now. If opening brackets are equal to n and closing brackets are equal to n and length of the string is also equal to 2n. So this is the perfect string that we have to consider. We'll push this into our answer vector. And we return from it. If this is not the case, there are two branches that we have to explore as we discussed in the dry run. In one branch, we will add an opening bracket. In the other branch, we will add a closing bracket. So look at this very carefully. So we will call the recursion function twice with the answer vector, the string, and opening brackets, closing brackets. So in the first one, we are adding a opening bracket. So we'll make opening bracket opening plus 1. In the second recursion, we are adding a closing bracket and O. So we'll make C equal to C plus 1 for this. So this is it. Let us try to run this code. Let us try to submit it now. So as you can see, the code has been submitted and our solution has been accepted. Thank you so much for watching the video. If you liked the video, make sure to like, share, and comment. If there is any doubt whatsoever, please comment it in the comment section down below. I'll be more than happy to answer all your doubts. Thank you guys. See you in the next one.